One of the more notable upgrades of 3.0 is we now support block-level data deduplication. So today I'm going to talk about our deduplication called QuDedup, and how because of it you need less space for your backups, but also because of deduplication the backups happen faster and take less bandwidth. Also, our multi-version backup with versioning is now much better because we can deduplicate the versions. I will also talk about our QDedup extraction tool and why you need to extract a backup that's been deduplicated if you want to read the files or restore. And then I'll talk about a new protocol we now support, TCP BBR, which can accelerate backups through the internet. So first, let's compare the new hybrid backup sync to the old hybrid backup sync. The old hybrid backup sync supported 8 cloud providers for synchronization and 13 cloud providers for backup. The new hybrid backup sync supports 22 cloud providers for both backup and sync. We support deduplication on the source side, and source side means we deduplicate before we send the backup through the network or through the internet. That means the backups happen faster and take less bandwidth because there's less data that we have to send through the network. We support TCP BBR now, which makes backups through the internet happen faster. And we have a more advanced schedule so that you can schedule up to 30 schedules per backup job. So let's get right into deduplication. I think deduplication is very exciting. So we offer block level data deduplication. And block level means that we're not just deduplicating the files that are duplicate files, but we're able to deduplicate the blocks within a file. So for example, this VM would be a single file. 15.48 gigabyte VM can deduplicate to a 7.5 gigabyte because the blocks within the file can be deduplicated. Now this does not just save space, but the backup happens faster, and that's because when you send the backup through the network, you don't have to send 15.48 gigabytes through the network, you just have to send 7.59 gigabytes in this case. Less bandwidth taken up, backup happens faster. And this is important because an estimated 81% of enterprises have adopted some kind of a cloud solution for backups. And the downside of cloud is that you cannot back up to a public cloud faster than your internet. And for most people, their internet is slower than their network speed. So speed can be problematic with public cloud, but if you can deduplicate before you send the backup to the public cloud, then there's less data you have to send. The backup happens faster. You don't bog things down as much for other people. Now we offer a pretty high compression ratio. So we're saying, 5 to 1 to 20 to 1 might be the kind of compression you might get in some scenarios, but it really ranges greatly. So in some cases, you can actually compress more than 20 to 1, but there's also a lot of cases where it wouldn't be as good as 5 to 1. I mean, if you don't have many duplicate files, or you don't have many duplicate blocks within a file, the space savings may not be that much. But in other cases, the space savings can be a lot. So I made kind of you can call this a best case scenario where there's many duplicate files. So I made many duplicate VMs. These are all the same VMs, just duplicate, so that these can all be deduplicated very well. And so in this case, I have 611 gigabytes on this folder. And when I back it up, my backup takes 19.4 gigabytes. Now, I want to stress this is a best case scenario. Most people won't have this many duplicate files. So I'm more just showing what is possible when there's many duplicates. Your space savings probably won't be this much. So not only will backups take less space, but they happen faster. So in this best case scenario, when I send the backup through the network, I don't have to send 611 gigabytes through the network. I have to send 19.4 gigabytes through the network. So the backups happen faster, take up less bandwidth, don't bog down the network for other people. One caveat though is that in this best case scenario, it's more than a factor of 30 less space taken, it's more than a factor of 30 less that has to be sent, but the backup's not 30 times faster. And the reason for that is that we can't, when you do deduplication, you cannot send the backup through the network faster than you can deduplicate. Deduplication requires a lot of file parsing and decomposition. And what we found is we can do that parsing and decomposition faster when the data is stored on SSDs when compared to HDDs. So when the data was on HDDs, they were sending the backup about 68 megabytes a second, because that's how fast they could parse and decompose for the deduplication. But on SSDs, they could send the backup faster. And so what I found with my best case scenario, because there's a huge amount of deduplication that can be done here, is that for the first, while I was sending the first VM image, it was sending about 60 something megabytes a second. When it gets to the second image, it's parsing through all those blocks to verify that none of those blocks have to be sent. And it goes to the next VM, parses through all those blocks, verifies that none of those blocks have to be sent. One by one, goes through the VM, look through all the blocks to verify, okay, these blocks don't have to be sent because I already have these blocks. And so what that looked like on the network is that at first, it was sending the backup at 60 something megabytes a second. But once it got past the first VM, it was sending almost nothing. It was basically going through the VMs one by one and verifying that there was nothing that had to be sent. So at first it was 60 something megabytes a second, and then there's some time waiting while it sends almost nothing. In my experience, for that one case, it was like 20 kilobytes a second for a while. So what all this means is that in this best case scenario, it's faster than if I had to send 600 gigabytes. That would have taken longer, but it's not going to be 30 times faster because there's some time waiting for the parsing and decomposition. But how much time that takes will depend on what kind of storage you use. So this will happen faster if you use SSDs. Also, this deduplication does take some significant CPU resources. So a more powerful CPU will probably have this happen faster. Also, keep in mind, because it takes significant CPU resources, if you have multiple backup jobs with deduplication, the backups should happen faster if you have the jobs happen at different times. It's probably best not to have many backup jobs happen at the same time because you could bog down your CPU. So our deduplication does mean you need less space. It does mean the backups can happen faster, but another benefit of our deduplication is that our backup with versioning just got a whole lot better. And that's because we can deduplicate our versions now. So in the past, with backup with versioning, if you wanted to say 30 versions, it would take 30 times as much space. But now, because we can deduplicate the versions, you can have thousands of versions without taking enormous amounts of space. So in this example here, having one version took 7.59 gigabytes, but two versions took 7.82. So that just took a tiny bit more for another version. And you can have thousands of versions without having enormous amounts of space, thanks to our deduplication. Now, when we deduplicate, we're doing a kind of archiving. And what that means is that if you want to restore from your archive backup or view files in your archive backup, you have to extract those files. So we've made an extraction tool. But to be clear, you don't need the extraction tool if the backup is on your NAS, because your NAS is able to extract from those deduplicated backups. But we've made an extraction tool so that you won't be dependent on your NAS to get your data. If let's say you back up to a public cloud. One reason to back up to a public cloud is, what if there's a fire and your NAS gets burned down? If you back up to a public cloud, you don't want to be dependent on your NAS to access your data. So we make an extraction tool for PC, Mac, and Linux. So our backups that are archive backups, they back up to something called a QDFF folder. And now if you want to wrap your mind around what an archive backup is, maybe you could think of like a zip file. I think you probably all had times when maybe you download something from the internet and it first makes it into a zip file so that the file's smaller, and then you can download it faster because you're downloading a smaller file. But when you download a zip file, you can't read from a zip file. If you want to read what's inside of it, you have to extract from the zip file. You have to unzip it or extract it, and then you can read what's inside. So it's a similar thing here. Now, this is not a zip file, it's a QDFF folder, but it's a similar concept because it's archived. You have to extract before you read what's inside of it or restore from it. So our QuDedup, we have a QuDedup extraction tool, and this tool allows you to select any version you want, and you can restore from any of the versions, and you can restore any file, any folder, or multiple number of files and folders, whatever you want. And because we have this extraction tool, it's now feasible to just take your backup anywhere and restore from anywhere. So you could back up to another NAS, but you can also back up to public cloud, back up to an external drive, even back up to a thumb drive. Take your backup anywhere and restore from anywhere because you have the extraction tool. So let's demo this. So I have a backup on my external drive. So you just double click on the backup QDFF folder. And if you've already downloaded and installed the extraction tool, then you just double click on the QDFF file. And it just automatically opens the extraction tool. And now I can choose any version I want to do the backup. So I can choose to extract everything, or I can choose specific files, specific folders. Just click on what you want to extract, and then I could click extract. So this is very simple, very easy. And because we have this, you can make a very robust backup scenario. So you can back up to a local NAS, back up to a remote NAS. You can back up to public cloud, to external hard drives, take your external hard drives to other devices, and wherever you've taken your backup, as long as you have the QDFF folder backup and you have the extraction tool, you can view your files anywhere. So having our deduplication already makes the backups faster because we deduplicate before we send through the internet. Therefore, there's less data you have to send. The backups happen faster. But something that we've also done to make the backups happen even faster than that is we support a new protocol called TCP BBR. And TCP BBR makes backups through the internet happen faster. To understand what TCP BBR does, I think it helps to know that one of the things the TCP protocol does is it regulates how fast the backups happen. So for example, if you send many files through the internet or network, those files are broken up into packets. And the TCP protocol will regulate how many packets per second are sent. And the reason it regulates how fast you do that is because if you send too many packets all at once, your network gets overloaded and it gets bogged down and it actually slows down. I think a helpful analogy is the freeway. If the freeway is at 90% capacity, it just flows. You know, people go like 70 miles an hour, and you might say that the throughput of that freeway is quite high. But if the freeway is over capacity, if there's too many cars on that freeway, it gets gridlock, it slows down. Maybe everyone goes 5 miles an hour. And then the throughput of that freeway is not so high anymore. So you don't want to over congest a freeway because then everything slows down. Well, you don't want to over congest your network because something similar happens on your network. If you send too many packets all at once, your network slows down. Everyone gets bad performance. So the job of the TCP protocol is to accurately determine how many packets per second your network can handle, and then send packets at the speed your network can handle. Not faster, because if it sends faster than what your network can handle, the whole network slows down. But not slower, because if it sends slower than what your network can handle, you're not making good use of your network speed. So you want to accurately determine what your network can handle and send packets at that speed. And that's what the TCP protocol is supposed to do. That's what the original protocol does, and that's what TCP BBR does. But TCP BBR has a more advanced way of determining what your network can handle, so it can make better use of your bandwidth. The way the original TCP protocol works is it just uses packet loss to determine when your network's over capacity. So it'll start setting slow and go faster, faster, faster until a packet's lost, then it cuts transmission speed in half. Then it slowly goes faster, 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 packet loss, cut transmission speed in half, faster, 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 packet loss, then cut speed in half. It does that over and over and over again. And this actually works pretty well on most, at least local area networks. In most local area networks, packet loss is actually a good way to determine when you're over capacity and when you should cut the speed in half to not be over congested. However, often when you send through the internet, many times you'll have packet loss even when you're not at full capacity. So maybe you're not at the full capacity your network can handle, but you get a packet lost anyway, and then the original TCP protocol will cut your speed in half, and then you don't make good use of your internet speed. So that's where TCP BBR really helps. Whenever it's a scenario where you have packet loss before you're at your max internet capacity, TCP BBR can help quite significantly. So we did a backup from Taiwan to London through the internet. And so this is a long distance. And whenever there's a long distance, it means your packets have to be forwarded many times. When you go through the internet, your packets get forwarded from router to router to router. Each time your packets are forwarded, we call that a hop. And whenever there's a hop, there's opportunity for packet loss. And the more hops you have, the more opportunity for packet loss. And then you start to have scenarios where a packet got lost not because you're over capacity. A packet just got lost because at hops, sometimes packets just get lost. And so when there's many hops, many opportunities for packet loss, what happens is the TCP protocol keeps cutting your transmission speed in half, even though you're not at max capacity. And the original TCP protocol does not make good use of your internet speed. So in this scenario from Taiwan to London, there was many hops, many opportunities for packet loss. And we found that TCP BBR made the backup happen 4 to 5 times faster. So that's a big difference. That's because there's a long distance, lots of hops, lots of opportunity for packet loss. So the original TCP protocol did not do a good job of judging what your internet speed could handle. And BBR was a lot faster. Now, on the other hand, if you send a shorter distance through the internet, there'll be less hops, less opportunity for packet loss. So I did a backup to my home NAS, and I live about a 20-minute drive away from work. So when I sent a backup about a 20-minute drive away, I found that TCP BBR made it about 20% faster. It was a shorter distance, less hops, less opportunity for packet loss, so the gains were still there, but the gains were less. And so how much you gain from TCP BBR greatly depends on how many hops, how far you go. Basically, the more opportunity for packet loss, the more TCP BBR helps. So let's demo Hybrid Backup Sync. Now that I've talked about all these features, let's actually show you Hybrid Backup Sync. So this is the overview. Here's where you can set up your backup jobs or restore jobs. Here's where you can set up your sync jobs. So you can do one-way sync, two-way sync, and you can do active sync. That's where you basically pull a backup from another device or server. Here's where you can see the jobs you've already set up. You can edit the jobs, or you can say start backup now. Here's the different servers, like you have to enable Time Machine if you want to do Time Machine backup. If I want to use rsync, I have to enable the rsync server. If you want to use RTRR, you have to enable RTRR. Here's where I can just see my local NAS. Here's the remote NAS I back up to. Here's the Google Drive that I've mapped onto my NAS, so you can kind of see that here. Let's go back to backup. So I can create a backup job, create a restore job, but let's actually just edit a backup job so you can kind of see the different options that you have. So first of all, you can hit the calculator to see the size of the backup that you're doing. 611 gigabytes is what I'm backing up. I'm backing up to a remote server. Here's the IP address. I'm backing up to the backup 670 folder. And my backup that's deduplicated is going in the backup 2.qdff. So when I go to schedule, you can set a schedule, and you can set up to 30 schedules. I could say one time, periodic. I could do like every 5 minutes if I want. I can do daily, weekly, and because I can set up to 30 schedules, I could, for example, say backup this time on Monday, backup a different time on Tuesday, a different time on Wednesday. You could back up a different time every day because you can set up to 30 schedules. And schedule is actually where you go to enable versioning. So I've chosen to enable smart versioning. I could just do simple versioning, but instead I've chosen smart versioning. So in this case, I keep a version every hour for up to 100 hours is what I've chosen, but I could do many more if I want. I do a version every day up to 60 days, but I could do many more days if I want. I do a version every week up to 30 weeks and a version every month up to 120 months. So what this means is I can have versions every hour, but I can still have versioning going back for 10 years. So under rules, one thing I want to point out is that if you want to do backup with versioning, you have to enable deduplication. So that's automatic if you do versioning. So for policies, there's things you can set, like I could set a limit rate if I wanted. So if I'm backing up to a public cloud, maybe I want to limit the speed so that I still leave internet speed for other people, that I don't want other people's speed to explode to a crawl. So I could limit that here, or I could just schedule my backup to happen maybe at nighttime. And there's other options like timeout time, things like that. So that's backup, but you can also restore. So you could restore from a backup job, just select the job and click restore. And source, so I just choose which version to restore from. Now this backup job, I've only actually made 2 versions, but I could choose which version. And then I could choose any of the folders in the backup to restore, or I could just restore the whole backup. But that's how I restore from a backup job. But what happens if you have a backup on your NAS, but you've deleted your backup job? Maybe you did a backup job, but you're no longer continuing to backup. So you deleted the backup job, but you still have the backup. Well, you can still restore even if you don't have a backup job. What you do is you create a restore job. And I could restore from remote cloud, remote NAS, or local NAS. I'm going to choose local NAS. And here I could restore from a backup job, but if there's no backup job to restore from, I could restore from a destination. So I could choose this backup job, backup1.qdff. And then here's my options. I could restore just the latest version, or I could restore the metadata. So let's say I have 1,000 versions. In order to get to the previous versions, I have to restore the metadata. Once I've restored the metadata, then I can select any of the versions to restore, or otherwise I can just choose latest version. So that's how you restore. So you can restore anywhere. So I mean, that's Hybrid Backup Sync. Let's go back to my slides. So that's Hybrid Backup Sync. We have a lot of options now so that you could, for example, back up your computer to the NAS, back up the NAS to remote NAS, and it'll happen faster because of TCP BBR. It happens faster because we have deduplication. You can also back up to a third-party server, back up to a public cloud, and these backups happen faster because of TCP BBR and because of deduplication. And you can restore from any of those backups. And that's because we have the extraction tool. You're not dependent on your NAS to extract from those backups. So this allows you to have a very smooth, high-performing, robust backup setup. So I think this is a huge upgrade to Hybrid Backup Sync. I think this might be one of the biggest upgrades I've seen us make to an app. I'm very excited about this, so I hope you make good use of this. I want to say thank you for watching. This concludes the webinar, but I'll be here for a little bit to answer some questions. Thank you.